welcome to today's video. Today we are going to be building a PDF embedded tables bot. We're going to do all of this in no code on the Model HQ platform, and all of it is going to run on the edge on our AI PC, and we're going to do the whole thing in a few minutes. Now, the goal of our PDF embedded tables bot is to address the document that you see on the screen in front of us. And this is a document that we have all seen many, many times. This is actually one page of a 100-page annual report PDF document. And what we want to be able to do is we want to create a customized business-oriented chatbot that enables us to engage in natural language queries, not against that document. What we really want to be able to do is ask questions directly to this embedded table that's within that larger PDF document. This is what we're going to go do in our PDF embedded tables bot. Let's go ahead and get started. We're going to build a custom bot template, and there are only a few key parameters that we need to do to get this set up the way that we want it. So we're going to build a new bot, and our bot is our PDF embedded tables bot. And the first thing that we're going to do is we're going to pick a model. And to do this, we're actually going to pick a large model. And one of the things that's really evolved over the course of the last couple of years, one of the more notable areas in which LLMs have really improved, especially small language models, is in their ability to actually read tabular information. And one of the best models to do this is the E9 billion parameter model. So we're going to specifically use that E9 billion parameter model, and we are going to choose it for the user because we want to make sure that we're using that model. It's all going to run locally. We're not going to provide specialized agent support because our use case is very, very specific to these embedded PDFs. We are going to use a semantic re-ranker. This actually helps us to figure out the semantic similarity so we can pick the right table in our document. And that's really all that we need to do from a model point of view. So then we're going to go on and we're going to add some files. And to get this started, we're just going to add a couple of representative documents that are annual reports. You could add any document. There's nothing special about these. These are off-the-shelf PDFs that we happen to pull from investor relations sites from these companies. And we're going to add those files to our bot. Next, we're going to do one of the other key steps in this process, which is when we're looking for this, we're specifically going to look at one table at a time. And I'll actually explain why that's the case. And that's not always the case in every use case. But for this case, when we're looking at large financial tables, we want to make sure that when we ask a question, we know in effect that we're asking it to one specific table so that we get consistent answers. So we're actually going to look for our best fitting table out of that document for any question. Again, that'll become clear as we dive into the example. The other magic thing that we're going to do here is this very special configuration called table only mode. When we turn table only mode on, any document that comes into our bot, it's automatically parsed. The text is extracted and indexed, but then it's filtered. Only text chunks that appear to be tables or tabular information are going to be considered. So automatically, this does a lot of what we want to do. When we ask that question, we can be certain then that the question is going to go to one of the tables in our embedded document to answer it. Now, we're not going to do anything too fancy with the UI, but just so we can see what we're doing with this, I'll just call this our PDF bot, called LLMware. And then just to make it a little more notable so we can see as we're going in and out of it, I'm going to change the header and the footer color. Just a subtle effect, but it'll help us to note when we're going in and out of the bot. And that is it. In about 3.5 minutes, we picked a model that's really optimized for table reading. We identified some off-the-shelf PDFs that we know have embedded in them some really large, complicated financial tables that we don't want to have to read. We want to be able to ask natural language questions and be able to get answers from them. We've set our RAG parameters, including this really powerful table-only parameter. And then we did a quick, simple optimization of the UI. And so with that, let's go ahead and let's run our bot. Now, the bot that we've created is not specific to any particular platform. It can run on almost any AI PC. But today, we are working on an Arrow Lake device. We are going to run and load that 9 billion parameter model on our Arrow Lake machine, and you will see the entire execution then and all of our interaction then happening on that Arrow Lake device. Let's go ahead and let's run. So what's happening is that all of those documents, those big financial documents, are actually being parsed and text chunked and indexed. And now our model is being loaded onto the device. We will be ready to go. And there we are. In our bot, the first thing that we want to do is we want to pull up some of our sources. And the example we're going to use is we're going to go back to where we started the video, actually a slide, the cash flow statement from this Amazon 2021 annual report. So we're going to do a bit of a deeper dive on that. spend some time asking some questions to. And now any question that we ask, anything that we write in this chatbot is actually going to be used then as a query, and the query will automatically go to that document source. And then we're going to find the best table to answer that question. That will be passed to our E9 billion parameter model, and then it'll generate an answer in a fact-based way off that tabular information. So the first question that I'm going to ask, and I'll explain why I'm framing it this way. So you can see we picked one table. So this was the table. It was actually our consolidated statement of operations table. We can get all the information about the sources. So this table was actually found on page 47 of the document. There were in total 8 tables that have been extracted from this document. And then what we see is we generated the answer to this, that the total revenue amounted to $469 billion. And then what we did is a reference check, going back and looking at the document to say, did we find a corroboration of that number? And we did. And we found it where we would expect to, with the total sales being 469,000 million. All right, that's one question. I want to ask a couple of more, and I want to explain why I framed the question this way. Now, as we were preparing for this demo and we looked at that first image that we looked at, that was actually the cash flow statement. And so initially we started asking the question, well, what's the cash on hand? And what we found is that we were getting some interesting answers that we're having a little bit of trouble reconciling. And so now let's actually ask that same question, but we're going to ask it with a little bit more precision. And first we're going to say, so the same thing as last time. We actually did find a table, and this was the balance sheet table. And again, we have our source information. And now the model is generating our answer based on that balance sheet. And note these numbers, 42 billion, I'll say in shorthand, 36 billion. So 2020, 42 million, 2021, 36. And now when we look at that balance sheet, we can see exactly where the model found that information. And yet it looks like it checks out. When we look at the balance sheet on page 49, those actually are exactly the numbers that we would expect to see. Now let's ask the question slightly differently. And let's say based on cash flow statement. This is actually what we pulled up at the very start of our presentation. Let's go ahead and let's run this inference. Again, you'll note what we did. So the first time we said, show us what the answer to that question is, cash balance at the end of these 2 years from our balance sheet. Now we're actually asking it from the cash flow statement. And this is where we initially got confused, because you'll see the cash flow statement, cash balance at the end of 2020 is 42.377, but look above on the balance sheet, it was 42.122. Similarly, the cash balance at the end of 2021, 36.477, above on the balance sheet, 36.220. Both of which are audited financials from the 10K of one of the biggest, most sophisticated companies in the world. It's not a typo. It's not an error. It wasn't the model hallucinating or doing something. It's actually a case of the complexity in complicated financial data, which is there might be minor discrepancies from the balance sheet to the cash flow statement to different ways of interpreting key parameters and line items. And here was sort of a beautiful example of it, where it had nothing to do with, well, why couldn't the model figure this out? We need to ask precise questions to make sure that we're getting precise answers. And that's why we actually started to frame the question of, based on the cash flow statement, give us the answer. Based on the free cash flow statement, balance sheet, just these minor differences between it. But what's beautiful is that in each case, we are able to actually verify that the information that we got is cash at the end of the period, actually that the numbers do correspond, and we were able to successfully ask our questions to those tables, get a generated response from our LLM, and then quickly validate that in fact that information was correct without us having to look at page 46 and page 49 and all of these pages embedded within the document. All right, so now let's go and let's ask a different kind of question. This is, we're looking for that needle in a haystack information, say based on the cash flow statement, which we just looked at. Again, this was what we looked at the very beginning. Reading through complicated cash flow statements, especially if you aren't a forensic accountant who can figure out why there's a difference between page 46 and 49, a few $100 million in cash, It's hard for business people to go through and do that kind of analysis. And so one of the use cases that we think is a really powerful one is now when you can ask a question, model, go read that cash flow statement. Help me write a really compelling summary that breaks out all of the key highlights that are found in that table, gives me a nice chunk of English I can insert into a report that gives me a good, clear view of what that financial table means and what are some of the key things that I should be taking away from that table. And so now we're seeing a really nice summary with all the key metrics, comparisons around it, even some interpretations of why certain things might be improving or changing, really nicely organized then, operating activities, investing activities, financing activities, changes in cash. Look at that. It looks like it just wrote the analysis that we needed to provide for our report. And then again, just like we've done in the other examples, we have a really detailed assessment that actually pulls out a lot of those key numbers and finds and confirms them in the materials, so we can verify that, in fact, it is using and drawing on the correct information that was in that table. And then we'll do just one last one. Now we'll go back to the question that we asked about company operations. Again, we can ask, what are the key highlights? And it'll write a very similar analysis we saw with cash flow, but now based on all of those key operational metrics around revenue and growth, all the things that we would expect in a statement of operations for the company. And then once we're done with all of that, we've just done a lot of work here. We were analyzing a 100-page document. We looked at some complex financials by just asking a few simple natural language questions. And then when we're done with all of this, we can actually download all. So this becomes a really nice transcript, something that we can copy and paste, extract, insert it, and put it onto a PowerPoint slide, Word document, or whatever final deliverable we need to go and produce it in. And the best part about all of it, all of this was produced entirely privately, running locally on our Arrow Lake AI PC, and 0 per token charges incurred as we go through this. So there we go. You can see a complete financial analysis of Amazon. And when we're done with this, this was just a standard PDF. There was nothing special. You saw all the work that we did to prepare it and to create this. You just load in the next PDF, or you move on to the next financial report, or you move on to the next year with Amazon. There is our analysis. And again, as always, then we get this nice view confirming the facts, and then we can just download it. This downloads it, and it becomes a really nice report that we can go look at. And this gives us all the information that was in that report. Hope that you've enjoyed today's session, seen how easy it is to do some pretty sophisticated business functions, creating our own PDF embedded tables bot in just a few minutes, and then starting to ask natural language questions to really complex financial tables. Hope everybody has a wonderful day. Take care. Bye-bye.